Hi you guys. We're on G3, special right triangles. As we start this, you've finished G2, which deals with simplifying expressions that have radicals in it. We're going to have to use that now as we talk about 45, 45, 90s on there. So we got some information in here. We call them special right triangles because they have a special quality about them, and in this case they both have, or they have 45 degrees, 45 degrees, and 90 degrees are the three angles. And so what is a 45, 45, 90? It's isosceles. This is going to be important with figuring out and understanding everything that's happening with these triangles. Two sides and two angles are the same. So when we have a 45, 45, 90, this one's 90, so these other two are the same because we have an isosceles triangle. So this is length A, this is length A, this is 45 degrees, this is 45 degrees. Because this is 45 degrees and it's measurement A, this is the same measurement angle-wise, and it's the same lengthwise of the side. So this is an important thing to know, that the sides are the same. If you know one side, one leg, you'll know the other leg. You don't have to do any math for it. Next on your notes, the question is this a 45, 45, 90 right triangle? And so I go like this, and I give you this, and I give you this. I don't give you an angle measurement. Can we determine that this is a 45, 45, 90 triangle? And the answer is yes, because the leg and the leg are the same. They're both 6. So in this case, you can say, and we don't care what the hypotenuse is, we can figure it out, but we can just identify it that yes it is. Now, what if I gave you 6 and 6.5 as the other leg? That is not, no, that is not a 45, 45 degree right triangle, because the two legs are not the same. This is not an isosceles triangle. All right, so let's get to how do we find the hypotenuse when you know the leg. And the rule is this. There is a rule to write in. You see the spot on your paper where it says rule? The rule is to multiply the leg by the square root of 2. When we know the leg and we need to find the hypotenuse, folks, you could use the Pythagorean theorem. I agree. Some of you are pretty good at it, but you don't need to. If this is a 5 and this is a 5, so we know that it's 45 degrees, 45 degrees, and 90 degrees, we multiply the leg by the square root of 2. So all you have to do is go 5 times the square root of 2. If you were going to do this with your calculator to actually find the distance, not in radical form, this is in radical form. If you were going to find the decimal of that, take your calculator, multiply 5 times the square root of 2, and you would get 7.07. So this is a lot shorter and a lot less math than having to do the Pythagorean theorem. And this is for the special right triangle 45, 45, 90. So this was example number 1 that I have. Example number 2 is a little bit more complicated. So there's our right triangle. It's 45, 45, 90. And one of the side lengths is 3 times the square root of 2. What's our rule? When we know the leg, to find the hypotenuse, multiply the leg by the square root of 2. So 3 times the square root of 2 times the square root of 2. From our last lesson, G2, square root of 2 times the square root of 2 is 2. It's the square root of 4, and the square root of 4 is 2. So this is equal to 3 times the square root of 4, 3 times 2, which is 6. Okay? So, how long is the hypotenuse? When this is 3 times the square root of 2, the hypotenuse is 6. Okay? All right. Next, what happens when we know the hypotenuse? When we know the hypotenuse, the rule is divide the hypotenuse by the square root of 2. So the other one was multiply the leg by square root of 2. Here we divide the hypotenuse by the square root of 2. Here is example number 3. I give you a triangle. It's 45, 45, 90. The hypotenuse is 8. What are the lengths of the legs? Divide the hypotenuse by the square root of 2. So this leg, we'll call it A, equals 8 divided by the square root of 2. Well, we don't like having radicals in the denominator. We learned that in the last lesson. So, we multiply square root of 2 over square root of 2. We get 8 times the square root of 2 all over 2. Oh, 8 over 2 reduces to be 4. So, our answer for that is going to be 4 times the square root of 2. If you want to do it with your calculator and multiply that out, you would get 5.7. Okay, so that was example number 3. Example number 4. We have a 45, 45, 90 triangle. The hypotenuse is 3 times the square root of 6. So, we divide the hypotenuse by the square root of 2. So, this leg A will equal 3 times the square root of 6 divided by the square root of 2. Multiply it by the square root of 2 over the square root of 2. 3 times the square root of 12 all over 2. We can simplify the square root of 12, remember. Square root of 4 times the square root of 3 all over 2. And what does the square root of 4 become? It's going to equal 6 times the square root of 3 all over 2. And do you remember 6 divided by 2 is 3? So 3 times the square root of 3. It seems like a lot of work, doesn't it? But if you're given just the hypotenuse, you can figure out the leg. And the last 2 word problems are actually pretty easy. I think you could do those by yourself. All you're doing on the last couple are making squares. And in number 5, 6 feet by 6 feet, what is the diagonal? 6 times the square root of 2. We learned that for the rule. Okay. The baseball field one, you can try that one. I'll have the answer on the answer key when you guys start correcting. All right, good luck.